Hi there. Do you hear me?
Yeah.
Okay. Good to see you.
Good to see you, Olav.
Good afternoon. Welcome back to this afternoon session on the second day of uRos2020. Before we go ahead in the session, just a short announcement or a short clarification. Since we are losing viewers in WebEx, but we are gaining viewers on YouTube, which might be logically because it's much easier to follow the stream on YouTube than to actually be able to connect to the WebEx meeting. So we thought it would be quite okay if you then post your questions on Twitter by using the hashtag uRos2020, so just hash uRos2020. And we will try to also monitor that and ask the questions then directly here in the live stream. Of course, it's quite understandable that clicking one link is easier than registering and so on, but you should not lose the opportunity or miss the opportunity to actually ask questions to the presenters. Okay, so with that, we can actually start the session. Bogdan is the chair for this afternoon session, and I will hand over to him.
Hello everybody to our afternoon session. Are in the organization and the introduction. We have only 4 presentations in this section, so I propose to give 15 minutes for each presentation and 5 or 6 minutes to answer the questions from participants. The first presentation today is DevOps and our experiences at Statistics Austria, and I will now give the floor to Bernhard to present this work. Bernhard?
Okay, thank you, Bogdan. I will try to share my screen.
Okay,
can you hear me? Can you hear me well?
We can hear you. We can see your screen.
Okay, that's perfect. So this is joint work with my
Just a second,
colleagues.
Bogdan, can you mute yourself because you are having some, yeah.
Now it's much better. Yes, this is joint work with my colleagues Gregor de CILLA and Alex. And I will try to outline the framework we have implemented that should facilitate the automatic building of internal R packages and the deployment of these packages. I will go through our environment, which consists of 2 Linux servers with RStudio Pro installed, a Git server, build server, artifact repository manager. So we decided to set up our infrastructure in a way that we have 2 server available. One we call the production server and one the development server, which is quite handy because we can test and implement changes on the development server before we are pushing them to the production server. These servers are Linux-based servers running Ubuntu, and both have the same software packages installed. Not only the system packages, but also the same versions of RStudio Professional and the same set of R installations. So we, in order to be reproducible, we keep all previous and older R installations available for our users, but at some point in time we freeze the update of the packages. Additionally, we have available the enterprise Bitbucket server, which is the Git server. What is nice is that this enterprise edition has support for webhooks and also has an API which we can use, and we are using, as I will show later. Then we have a Jenkins server. Jenkins is a build server which allows to build stuff and also R packages. And the last piece in our infrastructure is an Artifactory management system. We are using JFrog Artifactory, and we use it in the R context mainly to host a CRAN-like repo for our internal packages. So the idea is that all packages we are creating for house-wide usage should be available on this internal CRAN-like repo, so that everybody can just type install packages, but the maintainers, so we will do this for our users anyway. So the issue now is how can we connect all these bits and pieces together, and I tried to create some kind of flow diagram. Basically, the main idea is to have an RStudio project which is connected or is also a Git repo connected to the Bitbucket Git server. Whenever we update the Git repo, the Bitbucket server notifies Jenkins, our build server, that something has changed in the repo. Jenkins clones the code from the RStudio project, which contains some special information we will need later. On the build server, an R package we've written called buildstat is run, which decides what actually should be done. So it decides whether the RStudio project contains an R package or some arbitrary other R code. And then it does different things. So if we want to build a package, then it builds, checks, tests, documents the package, and allows optionally to deploy it to the Artifactory management server. So it's available on our local CRAN. If it's not a package that should be built, then it just runs the scripts and code that is in there, and we optionally can specify that results should be deployed somewhere using Linux system tools like async. And if everything succeeds, and also if it does not succeed, so the users get notified via email. So build start creates a markdown report summarizing the successful and possibly steps that contain errors. So it's quite easy to debug. So as we can see from the flow diagram, there are quite a few connections required. So we need to connect our Studio project to the Git server, to Bitbucket. Bitbucket needs to notify the build server, and we can do this via a webhook. So the build server, the Bitbucket just sends an HTTP request to Jenkins to notify the build server. And then Jenkins needs to make sure of some special files that need to be included in the RStudio project, in the code, to determine which base Docker template should be run. You can specify the R version there, as we will see in a minute, and set up the parameters for the pipeline run. In these configuration files, one can set a lot of different options, but the idea is that if you want to build an R package, that it's quite easy that all the dependencies are resolved, and documenting, building, checking, and deploying is easy. And the same goes if you don't want to build a package, but also an ordinary R project. So what are these special files I was talking about? It's actually two files that are required so that these connections work. We need to add a file called Jenkins file, which basically states the name of the Docker file which should be used when building the project, and a file that contains a YAML file that contains the actual settings and options that should be used. And in this configuration file, we can, for example, specify additional system packages that would be need to compile stuff, or we can define who should get a notification email. How should we deal with warnings or notes? Because sometimes there are notes that are actually quite helpful, and you don't want to remove them for internal packages. And you can specify if on a successful build, the package should be pushed to the Artifactory or not. So you can also specify that you want installation available when building the package, and run additional scripts at various points or stages of the pipeline. The scripts can be run in can be Bash, Python, R scripts, whatever. The config file has quite sensible defaults. So as you can see on this slide, they can be quite short. So the first few lines here is the Jenkins file, which has a fixed format. It needs basically to say the name of the pipeline that should be run. So it's the R pipeline YAML, as we call it. Then you specify the name of the Docker image, where the available images correspond with the R versions we have installed in our environment. So for now, the latest is the 4.03 version and specify a path to the configuration file, to the YAML file. And the YAML file, in a very easy example, can look like this. So we specify who should be notified, and for example, that the R packages that are installed on building should be cached so that additional runs are faster, because only updated packages would be installed. So for us, the requirement, or one of the requirements, was that we wanted it to make it easy for us to actually use this setup. So we wanted some easy way to allow the automatic connection of these various software components. And the idea was to create a workflow package which is similar to use this. So we called it use stat, and which basically exploits the available REST APIs from Jenkins, Bitbucket, to set up the required connections. So I can't show it live due to the time constraints, but basically what we do is, or what you can do, you can call a function which is called create stat package, which creates a new R package with some internal template. Then you can run use git and use stat bucket. Use git creates a Git repo for this new package, and use stat bucket makes the connections from the RStudio project to the Bitbucket Git server. And then you can create a Jenkins job and link this Jenkins job with the Git server with the use Jenkins function. And this is everything what's required. On the first run, you have to set up some authentication, which are internally stored in a secure and safe way using our outstat package. And whenever you then add some commits to your package and push them to the Git server, Jenkins will automatically build the package. So what are the pros and cons of this approach? I would say the pros is that the major advantage is that it's quite easy for people without any prior DevOps experience to set up a new package. For us, maintaining this installation, and advantage is that we have consistent package definitions, because in the pipeline, before we push a package to our internal repository, we can, for example, update the description files by adding the specific Git ID, commit ID, so it's easy to reproduce the setup. And we have some consistent quality check across all internal packages that are uploaded to the Artifactory repo. There are some disadvantages too. We have to deal with authentication against various services, against the Bitbucket server, against Jenkins, and we have to maintain some internal packages for this. And also it's quite tedious to update the pipeline, because all the tests have to be run in Docker containers, so it's not so straightforward to test them locally. But overall, we saw a few problems, and in our view, the cons of the initial setup outweigh the benefits, which are mainly consistency, quite a bit. And we are also quite happy that we can add new features like the dealing with secrets in pipelines quite easily in one single central place, which is the build stat package. so it's quite easy to maintain. So this was already my last slide. I hope I could give an overview how these nodes play together. And if you have any questions, I will try to answer them. Thank you.
Thank you very much, Bernhard. We already have some questions from audience. I will read you one of them from Martin Liebers. What was the reason you chose to use Ubuntu as a Linux distro for the development and production servers?
Sorry, I wasn't able to hear the question.
What was the reason you chose to use Ubuntu as a Linux distro for the development and production servers?
Okay, well, it actually was not our decision. I forgot to mention that all of this is only possible if you have good connections with staff at the IT department, because in our setup they are basically managing the server infrastructure. And I think the main reason for choosing Ubuntu is that there is a long-time support version available. So we're using Ubuntu 18, which is, I think, supported for the next 3 or 4 years at least. So there is no immediate need to update the servers.
Okay, thank you. And we have another question here. Are there plans to make this more generic so it can be shared?
Sorry, I wasn't able to hear it again. Sorry.
Are there any plans to make this more generic so it can be shared?
The internal packages, well, I'm not so sure if it's possible because they are quite specific to our internal infrastructure. So I'm not sure if they could easily be applied in our setups.
Okay, thank you. And I have a question. How many users do you have internally for this software structure?
It's funny because I just looked it up in the morning. So on the development server, it's quite a small number, which is intended. So we have basically the methods unit and some selected colleagues. On the production server, we have around 230 active users, and I just looked it up. We have around a bit more than 50 users that had the last 30 days more than 12 or 13 computing hours. So they were actually doing something.
Okay, thank you very much. If there are no more questions from the audience, I propose to move to the next presentations. Thank you very much, Bernhard. The next presentation is called the Awesome List of Official Statistics Software 100 and Counting. And now I invite Olav to present the results.
Yeah, thank you. Can you see the slides now? Yes? Okay.
Yes, we can see them. We can hear you. Okay,
then I'll start. Okay, my name is Olav ten Bos from Statistics Netherlands, and I want to inform you about the Awesome List, which is probably known by a lot of the participants already if you attended one of the previous uRos conferences. I do this work with Mark van der Loo and Alex together, and I want to talk about, first of all, what is the Awesome List? A bit of history, the concept, and the status. And then I want to zoom out a little bit of what it is now. What is the goal that we actually want to achieve with this list of statistical software? Talk a bit about reuse, building blocks, and communities. And then finally turn towards this particular conference, the uRos, in relation to the list, which is actually very important because we want to upgrade the content of the list. And actually, it's all about statistical software. So to start with, what is the Awesome list? It was born in another conference, the Statistical Data Editing Conference in 2017 from UNECE in The Hague. And I think it started with a few of us that enjoyed the excellent talks and all the presentations. And of course, there was also some software being presented. And then you think, okay, I have to remember this. And we all have a kind of short list in our minds of useful software that's around in other institutes and that we could at some point reuse. And then we said, okay, it would be good to write it down. And if we write it down, all these lists that we have in our mind, then we have a growing repository of the software that we want to use jointly. So we created this list from the statistical computing group in the Netherlands at first, but actually it's a community-owned list. That's the purpose, a community approach to knowledge management. And then we use this awesome concept. And for those of you that are a lot on GitHub, you probably might have run into one of the awesome lists, which were created by, the concept was created by Sindre Sorhus, a famous open source developer. And he also had the problem remembering too much. And if we then use GitHub, let's say, to maintain this knowledge, start simple, define some criteria, then we together maintain that kind of list. And this list is the awesome official statistics list. And this is the address. If we type it there, then you will arrive at the list. This is a screenshot of the GitHub page. So it probably looks familiar in the setup. It's just a repo in GitHub, which is called Awesome Official Statistics Software. And there are clear criteria of what we want on the list. That's also one of the principles of awesome lists. So we formulated these criteria. It has to be free and open source. We strongly believe that if we want to reuse software from other agencies, it has to be open source. And also available for download, preferably with just one mouse click or something, very easy. And the second criterion that we formulated, it's confirmed to be used in the production of official statistics by at least one institute. So that's maybe your own institute, of course. It's good to show some maturity in a solution before putting it on the list. So, and there's a special other category. It could also provide access to official statistics publications. There happen to be a lot of software around which is access to statistical dissemination databases. So this is centrally on the list. There's of course an open license. We use the social interaction mechanisms that are standard. You can watch, unstar, star, and fork. And very important, there are some guidelines to contribute to the list. Pull request, issue tracker, or just send it a mail. And you see that just out of the box, we also see that a lot of people contributed. What's on the list? Well, this is an example. The list is organized in GSBPM processes, which is the generic statistical business process model, one of the standards of the UNECE. And in this example, you see the category, the SDC category, and let's say almost 12 pieces of software, mostly R packages, some are Java, which are actually very generic, usable in the SDC. And I think a lot of people know this, and it's good to see them listed. And if you have an SDC problem, then you could look what is there already. And it might be specific, it might be very generic. Another example, another category is data integration and record linkage. I won't go into that too much. This kind of category is scraping for statistics with today's web knowledge and web data. There's a lot going on in official statistics on web scraping. So actually, it's not a category in the GSBPM, but we think it belongs to GSBPM 4.3. And you see there's no R software here on the list. It could be R because you can R in web scraping, of course, but this happened to be donations on the list, which are mostly in Java, Node, and Python. And this is a very large category with the access to official statistics, which is also like standards SDMix and that kind of software and standards, or software supporting that standards, I would say. So this is to give you an idea. Have a look at yourself if you're interested, please. There's another feature or thing that's on awesome lists. We created a badge. The badge is somewhere that you can put on your page or GitHub page or another page, and then you wear the badge. So if you're listed on the list, you can wear the badge, and this is an example. Sampling strata was presented in the beginning of this conference and is on the list for a long time already. So apart from the regular badges, there's one specific badge mentioned in the awesome list, and it links then to the list, which improves the findability on the internet. So the more software packages on the list link back, the easier it is to find in search engines. This is another example from the .stat community, from the OECD, the .stat system, where they put a badge on it, and others do it as well. The Tau Argus for statistical disclosure, and small count routing, it was mentioned today already. Okay, to give you a feeling about this GSBPM, as far as you don't know, this is the picture of the GSBPM. So you have overarching processes that are generic for all statistical computing, let's say. And then you have sub-processes. The blues are the vertical ones: specify needs, design, build, collect, process, analyze, disseminate, and evaluate. And you have detailed processes. And you see here that visualized where the current items on the list are placed. This is not always completely clear. If you have a very generic package that could be applied in multiple processes, then it's just that. But we do our best to give it a place in this process architecture. You see lots of them are in the process which is logical. That there's a lot of generic software in statistical processing, in validation, review, in integration, in aggregation. We've seen some today. And the other category is in the dissemination. There are lots of them there. Okay, so that's what it is today, and look yourself. But I ask myself, what are we actually trying to achieve here? What do we actually want with this? So I already told how it started, to remember what we all know. But in the end, we want to reuse statistical software. Because, why? Why would we want to reuse statistical software? There are plenty of reasons, actually. One of them could be costs. So if we develop it once and use it by many, then as a community, we are, of course, more efficient and effective. The quality is a good reason, because if you redevelop something, then there's a lot of effort in. But if you use well-tested and proven implementations, then, of course, it adds to a good quality of your statistics. We maybe can act quicker if we have these standard building blocks, which we can just connect them and create a new statistical process. And of course, it might also add to standardization in the implementations for official statistics. We use the same implementations. So what is our view on these basic building blocks? Especially the last couple of years, with a lot of new data science techniques and methods, the landscape for official statistics software is getting more complex and diverse and dynamic. So it's even more important to have this knowledge around. And ask us the question, what are proven and successful building blocks for official statistics? And in an ideal scenario, this would be kind of blocks that are configurable per domain. And let's say per NSI, per statistical organization, you put the knowledge on a statistical domain into it, and it is a standardized input and output. Like here sketched to databases, or SDMX, the statistical standard for metadata exchange, this, or CSV simply in JSON or R data. And in an ideal scenario, they will be chainable. So we could build these processes out of the readable available blocks, and these blocks, we get them from some software repo. That's ideal. And then you might say, okay, but we have this ideal world already. We have cron, we publish on cron, and we just install it. And that's absolutely true. Software sharing is already happening. That's true. But it's not only the R community. There are different communities, and they all have their own repos and package system. You have a big NPM community, and also a very growing Python community. And Julia is coming. To make it even more complex, or there's also, let's say, from the UNECE started the CISPA, Common Statistical Production Architecture catalog. And this is interesting, more a top-down approach on software sharing, where I think the awesome list is more a kind of bottom-up approach. So we list what's there, and we try to make things reusable, or list the things that are reusable by many. So right now, the majority of the items on the list is R. Here's a chart of packages by programming language, and the growth is we are now on 102 and counting. And one of the reasons that it is majorities R might be that we did some advertising, and some of you probably are here on these pictures of the previous uRos conferences. It's a pity that we cannot do it virtually. We have to do it virtually right now. Maybe next time, better. Preparing for this, I had a view on actually all the abstracts of this conference to see, okay, because the content on the list is the most important one. These are some software packages or pieces of software, or they might not even have a name yet, that were presented on this conference already, or in the abstract, like the MD and the Quantreg. Very interested by Norway, for instance, about classification management, the class R, which gives access to the Stats Norway API. So I have immediately the question, what about other APIs? If it's generic and usable, it would be of profit for all the community. Very interesting talk about classifying non-profit organizations by field of activity. The Swiss cheese, the SDC log. We have seen the OCR of unstructured annual reports. Well, I can say you in the Netherlands, we also have unstructured annual reports. So if there would be a generic package, then it would probably be applicable. The input-output tools, wild. I happened to see that there's a work in progress on GitHub on the cell key implementation for SDC and adding random noise. And they say you use it for your own good, and it's going to be improved. So there's probably a candidate for the list as well. Time series with SQL. This morning, the migration analysis, it's already on GitHub, and they have plans for CRAN, they say. And we've seen the hierarchy computing, and just the talk before this, the DevOps in R and all the infrastructure. Could it be generalized? So concluding, this is the list. This is the URL. It's a community instrument to reuse generic software for official statistics. And if you think you have these basic building blocks that are not yet on the list, and are used in the production or somewhere, and if you think there are valuable basic building blocks for others, it's reasonably well documented and preferably easy to install, then consider sending us a mail or whatever. And questions, ideas, suggestions are always welcome. Okay. Thank you for your attention.
Thank you very much. So if you have questions from the audience, there was a note that the link to GSBPM is great, and since the GSBPM is a standard in the European statistical system, this list should be added as an official annex. It is not a question, but a note. Okay, another question. Do we still need a CSPA if we have the awesome list?
Do we still need the CSV? The
CSPA.
The CSPA. Okay, good question. Well, the way I view it now is, in fact, the goal that we have with the awesome list and the goal that the CSPA community, which is partly might be the same, have is reusing generic building blocks. So the goal is the same. The only difference, or maybe big difference, is the way we progress. And there I said the CSPA is more top down, because they started with, it has to be a service and it has to be like CSPA compliant with strict rules. It's now tightened, more flexible, I think. Where the awesome list said, okay, there is so much software sharing already going on, and the challenge is to get it known and to try to generalize it. And it would be great if they meet somewhere. And this is also what I talked about with the CSPA people, and we want to achieve something like that. But then it's crucial that let's say statisticians, like in this conference, let's say R-minded scientists and scientific people talk and understand, let's say, architects, which are more on the CSPA side. So.
Thank you very much, Olav. If there is no other question, it is time now to move to the next presentation. From Airflow to Docker, R in open source production environment. I invite now Matthias from KOF, Swiss Economic Institute, please.
All right.
The floor is yours.
Yeah.
Okay,
all right.
You can see the screen now. Yes.
Can you see my screen?
Yes, we can see it.
Okay, perfect. Hello everyone. My name is Matt. I'm a programming with data person at KOF, Swiss Economic Institute. And first of all, I would like to say thanks to Alex and Bogdan and the entire team for really setting this conference up, and despite all the adversities and the postponing and going virtual. And I mean, like from the last talk, I heard about the awesome list, but I kind of didn't put any effort in getting there, and it was good to have a reminder. And apparently, some of my time series buddies are already on that list, and I didn't really have it on the radar. So it's really important to talk and have this opportunity. So thanks for sharing. It was really relevant to what we do. Yeah. Okay. Today, I would like to show how we use R within an open source production environment, very similar to the first talk. And I think it will be interesting to see the differences of how we deal with a similar problem. All right, when thinking about production, when wondering about production, the first question is, what is the product? And obviously at KOF, we ain't flipping burgers, so we shouldn't think of KOF production as a Five Guys type of kitchen. Our product is economic statistics, and for us, economic statistics is mostly based on business tendency survey data. That means we have firm level data coming in, and we aggregate it to the time series level for regional time series, sectoral time series, and then we build indicators on top of that, do forecasts with it. So we can say that our product, so to say, is our standardized product that we quality control is a time series. that's the product. And that's, as I like to say, we want to know that the butler did it from the get-go. So I'm going to show you our product first and some very concrete products so you can see what our time series look at in the end. So first thing, KOF Swiss Economic Barometer, that's the main forward-looking indicator for Switzerland. And obviously we publish that on the website of our institute. And as you can see, there's an interactive graph that you can play around with. And this graph is fed by our database. And so are these little links here where you can download data. I hear a lot when talking to people working in official statistics that they have to deal with content management system, asset management system. For our institute, that's not the case. The moment the data is up to date and being cleared to be published, it's online. And based on that infrastructure, we can also use a tool like this. This is a web application that we built in-house, where you can search our pool of close to 500,000 time series or even more than that. And with a couple of filters, you narrow them down to only 100 and you get meta descriptions and all of that and get a little preview so you see what you're looking at and so on and so forth. And of course, there's also still print output. It's still there. We produce a lot of PDFs still that look like this. We have a report and people actually read that, and we have it in 2 languages. And all of these graphs, they are just produced in automated fashion, put together from the database. This is done in an R environment. So what all of these 3 outputs have in common is that they are basically produced with this type of infrastructure. So there's Docker. Probably there's not a lot to say about Docker within this session. Everybody knows Docker. Then we have Apache Airflow, which is kind of cron jobs on steroids for us. And then we have GitLab CI, which is therefore our continuous integration pipeline. And yeah, what I want to do now is first give you a little bit of a general overview of how we use it, and then run you real quick through an application example. All right. I think it's worth picking up those of you who haven't heard a lot about Docker and not really familiar with the Docker terminology. Think of Docker as a single-purpose computer, a computer that dies after it's done its job. So there's an environment. These environments live in containers, and containers are based on blueprint, based on images, and images are blueprints for these containers. Then we have registries, which are kind of repositories for images. And then we have Docker files. Docker files are just text files, configuration files that you use to create Docker images using your Docker runtime environment. And then Docker images can be stacked. I think this is very noteworthy because you can go and get from Docker Hub a tidyverse, a professionally created image, and then build your own little image with your. So that's basically Docker in a nutshell, the way we use it. If you look at it more specific to our use case, you have to distinguish between 2 types of containers. There are permanent containers and there are non-permanent containers. Permanent containers are pretty straightforward. They are just like normal web service, like a virtual machine. We host our database, our Apache Airflow, and also our mini CRAN, which is kind of similar to what Bernhard presented. It's just like the big CRAN everybody knows, just for internal packages and those that we want to keep the versions freezed. Then we have our custom Docker registry, so we don't use Docker Hub for our own Docker images. Comes from our own Docker registry, hosted inside a Docker container, by the way. And then we can we use it a lot for APIs to expose our data to the outside for data dissemination, and it's easily interchangeable, which is interesting. So if we put our money on Plumber, we can easily switch to a node-based environment like Express or whatsoever. A little bit different than that are the non-permanent containers. And this is best understood if you look at the little sketch over here, where you can see, okay, we have got a bunch of task-specific images, for example, reporting. That can be a pain to set up. Just remember LaTeX and all of that, PDF production fonts and all of that. That's really cumbersome to set up at times. So it's nice to have a container and environment that's not mingling with other setups. So what we do here is we have our Airflow, which is kind of the orchestrator. There's a start signal to start the process. Then we have the Docker registry where you have all these type of images. And then we have a GitLab repository where some R code lives or some Python code. And then we put all of that together and make that R code run in that particular environment. And before the container dies, it puts the data or the result into a database or a network storage, and that's that. Then the second tool on the list is GitLab CI. I mean, GitLab CI, most of people nowadays use GitHub Actions, but this is kind of our on-premise hosting of a continuous integration environment. We use it for building packages. So what it does is build and test our packages, then push it to our mini CRAN, and from there on deploy it to the server. A little bit more technical, this looks like this. We have a couple of stages. If you look at the YAML file, the configuration of this, there's build and check. Then there's CRAN, see the pun, like CRAN with a K, the cough CRAN, and then deploy that to our production service, which is RStudio as well. For our case, the open source RStudio server was enough, but it's basically the same here. Then, as you can see, check is we're using the Rocker tidyverse image, and then we start to install the package from our mini CRAN, and then build this. And yeah, once all the checks are okay, it's going to be deployed on our RStudio service. Then the third component is Apache Airflow. I think it's the least known component in the mix. So yeah, there are about 4,000 Stack Overflow questions. So it's not that big, but also not a super tiny project that nobody uses. It's a workflow scheduler. And what it does for us is it provides us with a nice overview for a lot of cron job type of processes. We see what's going on, what is scheduled at which point in time. And the second thing is the workflow itself is defined in Python, but there is also a nice overview that people call directed acyclic graphs, which is a visual representation of how processes are running in parallel or running sequentially. And this is what Airflow does for us. So now that you've seen the components in a general fashion, I would like to walk you through an application example. This application example is called Swiss Data. It's a project where we gather data from a lot of public sources, from ugly spreadsheets of all sorts, even from PDFs, and put it in a homogeneous time series format, and at the end, read it into our PostgreSQL database. So here is the DAG for the Swiss Data project. So here's all the web scraping and the disentangling of ugly Excel spreadsheets going on. Then we source it to our database, and for some instances, we run transformations such as seasonal adjustments if the original provider doesn't do it. And this is the entire DAG. And let's look at two examples out of this process a little bit more in detail. There is a task-specific Docker image. So to run Swiss Data, to run all this scraping, we need a lot of R packages, because that's one of the big strengths of R interfacing with all these ugly spreadsheets, ugly sources, all these odd sources. So we have our Swiss Data Docker image, which has all these packages installed. And then we mount the volume right here. So our network storage, and then the Swiss Data output gets stored there. So this is an example of a task-specific image. But we also have like standard image and a standard that goes well for most tasks. So we have our COF base. We mount volumes again. And then also as same as we set it with Bernhard explained, we can pass on passwords and such through the environment. So this Docker container can be used to run a database storage process. And that's everything this task does in this instance. So the role of R, what does R exactly do in this? Of course, it helps us handle with dependencies through its package architecture and the mini CRAN. Then, as I said before, it's really, really good at interfacing with all of these sources, from reading Excel, transferring time series, reading YAML, the entire web scraping thing. There are really a lot of packages really standing on the shoulders of giants here. And then we use our own time series DB package, which you can listen to in another pre-recorded talk that we use as a database interface layer, so to say. So is R any good at this? I think it's really good. I mean, dependencies are managed reasonably well, and we can use Docker to mitigate some of the weaknesses compared to other non-R architectures. Then I think our interface is incredibly well, as I said, and also I think it's very inclusive. It's interpreted, it's free. Students can use it. At KOF, we have a lot of students coming in, working with us as assistants, and they can easily pick it up thanks to all the nice material online. And they can run all these Docker processes on their local machines, because they can run R in there, they can run Docker using Docker Desktop and all of that stuff. So we really tell them how to do this, and it's easy for them to pick this up and develop our methods before they go into production. Yeah, I think this is for me. If you don't know the resources that I've shown, I think the Rocket project is something you should have a look at. Also, if you want to look at, ever wanted to try out things like Shiny Server, there's a Docker image, you can run it with a single line. This is really a great project. And Apache Airflow, I think this is a project a lot of people pick up or give a look at because they didn't know it before the talk. And then you have Minikran and GitLab CI, which are of course a little bit more known in this session, I think. Yeah, other than that, I just want to say let's stay in touch. It doesn't stop at the conference. I hope to have an exchange with people interested in these topics. And yeah, thanks for the attention. That's it for me.
Thank you very much, Matthias. So if we have questions for the participants, please write them on the Q&A section or on Twitter. So it seems that there are no questions, and I have one question here. How many persons do you need to maintain this infrastructure?
I think this is a very good question. I also looked it up to ask the same question to Bernhard. I think it's one and a half for us, but we also do other things. We had a big push to set it up where we were busy like for 2 or 3 months, mostly doing this stuff. But now to maintain it, it's not even 1 person 100%.
And how many users do you have? How many users of this platform do you have?
We got a head count of around 90 at the Institute, and I also think for the production use, we have 50 regular users, very similar to what Bernhard said, but I mean, on the dissemination end, it's much more. Our API is used to exchange data with the National Bank, with the Secretariat of Economic Affairs, and a lot of cantonal statistical, regional statistical offices. So there it's probably thousands of users. It's hard. We don't track them, but it's way more than that. But for the R environment, it's maybe 50.
Okay, thank you very much. Another question here, were they free to choose the tools, or there are restrictions from the IT department? I think.
Docker helped a lot in this, because what the IT department says, okay, we are going to present you with a Docker host, and within the Docker, we could do basically what we wanted. So we kind of, it helped us to went by a lot of restrictions actually. And also the problem was for us, as good as our IT is, our use case is very specific, and they don't know all these tiny little bits of LaTeX or R setups. R they learned because we've been using it a lot in production since 2012, but I mean, there are so many tools coming up all the time, so they're not able to keep up with that because they got other stuff to do as well. So Docker really helped to be our own boss, so to say, for a couple of things, not for everything, but it helped to went by restrictions as well. Yeah. And even if that's not possible, as I hear from other institutions which are stricter, it helps to have a local proof of concept within Docker, try everything out, and then give a detailed instruction to the IT what you want, even if they have to implement it for us.
Okay, thank you very much, Matthias.
All right.
It is now time to move to the last presentation in our session today. Persephone process-oriented facilitator for RJDemetra, including support for hierarchical time series. I give the floor now to Angelika from Statistics Austria.
Thank you. Hello, my name is Angelika MERANER, and I'll be, oh, sorry, I didn't share my screen. Okay, is it working? Okay, great.
Yes, we can see you.
Okay, so I'll be presenting Persephone, the R package that we are currently developing at Statistics Austria. Our objective was to either improve or replace the R package X12 that is currently used at Statistics Austria for seasonal adjustment.
Angelika, just a short interruption. Can you put it on full screen, the presentation?
Yes.
Please.
It does not work with.
No, you have to press Anzeige and then, yeah.
Okay. Okay, so we wanted the new or enhanced tool to fulfill the following requirements. It should enable the easy processing of multiple time series during the production of seasonally adjusted estimates in an official statistics setting. It should support hierarchical time series and weighted aggregate series, and most importantly, it should work in R. Now, with the release of RJDemetra and our interface to JDemetra Plus, the Eurostat recommended JD Plus seasonal adjustment software became available for R users. And so we decided to build a wrapper around RJDemetra to fit our needs. This means that the package Persephone actually builds on top of RJDemetra. But Persephone provides the seasonal adjustment infrastructure for official statistics. So this means for dealing with multiple, possibly hierarchical, monthly or quarterly time series. Functions of RJDemetra performing seasonal adjustment are called in the background. The package is available on GitHub right now. It is still under development, but it will probably be released on CRAN sometime next year. Now, in the following slides, I'll show you how to work with Persephone. So how to construct a Persephone object, including 2 examples, and I'll conclude with our to-do list of future enhancements. Okay, objects of class Persephone, which are our 6 class objects, can be constructed from only one or multiple time series. Multiple time series can be connected through a certain hierarchy, and weights can be assigned. These weights can be either time variant or time invariant weights. Batch objects without a hierarchy can be represented as objects with a flat hierarchy at the moment, but this will be improved in the future. So first, single Persephone objects are corresponding to univariate time series objects are constructed with the functions per x13 or per tramor, depending on the seasonal adjustment method chosen. So the x13 are REMA seeds or tramor seeds. And secondly, multiple single objects can then be combined with per HTS. HTS standing for hierarchical time series, to build a hierarchical Persephone object. Now I'll continue with two examples. The first example will be a Persephone single object, and the second example, a Persephone hierarchical object. To create a Persephone single object from a univariate time series object, a predefined RJDemetra plus model specification has to be provided by the user. So, for example, RSA3, which basically stands for automatic model selection. So, as you can see, we load the air passengers dataset, and we call the function per x13 to create the object x13. And now different methods can be called for the Persephone object x13. Most importantly, the run method, which performs the seasonal adjustment itself. Yeah. Done like that. And before the first run, some methods for the object will not work. Well, most methods will not work. And some fields will be empty since no results are available yet. The output field gives access to the original output object from RJDemetra, which would look like this for the RSA3 predefined model specifications and the air passenger dataset. We can change the predefined J+ parameter settings with the update params method. And in this example, we include some random outliers, which is done exactly the same way as in the RJDemetra package. And then we perform another run to make the magic happen. The output now shows that the outliers are included in the model. We can see here an additive outlier, a level shift, and another level shift. The random outliers that we included before. Several plot methods have been implemented with a focus on using interactive tools. So, for example, the default S3 generic plot shows a zoomable line representation of the series. Here have the original series, the seasonal adjusted series, and the trend. All the plots in Persephone were either generated with the digraphs package or a combination of ggplot2 and plotly. And this default S3 generic plot was generated with digraphs. Now, other plot functions include several interactive plots in connection with residuals, interactive plot of the seasonal component, the irregular component, and the calendar effects for Persephone object, an interactive plot of the SI ratios, and in case of X11 of the seasonal factors per period, and spectral plots. Now I'll move on to the second example, the Persephone hierarchical object. The package includes data to be used for examples and tests, monthly, calendar adjusted, seasonally adjusted, and unadjusted data published by Eurostat. They are multiple time series objects of the volume index of production for total industry of the EU 28 countries from January 2000 to June 2019. The package also includes the corresponding weights. Now, for this example, we use the calendar adjusted data after performing some pre-adjustments to create a list of Persephone single objects, out of which we can then construct a hierarchical Persephone object. So here we basically just remove some missing values from the data and construct two vectors of country names that we will need later on, the Euro area countries and the EU 28 countries. So these two vectors. And now we generate a list of Persephone single objects with X13 as method for all countries time series. This can simply be done with lapply here. In the next step, we use per-HTS to aggregate the 19 euro area countries and set the method to be used for the direct adjustment of the aggregate series to X13 as well. This done here. So you can see we select the euro area countries from our list of Persephone single objects and pass it to the list of parameter here of per-HTS. We then generate our final hierarchical Persephone object, HTS uRos2020, which consists of the euro area countries as a hierarchical object and the remaining 9 countries as single objects. So here we pass a list of 10 elements, our HTS object here of the euro area countries, and a list of Persephone single objects corresponding to the non-euro area countries. The structure of this object is represented in the print output. You can see the blank component is the overall total. Next comes the lower level aggregate series EA19, then its components from Belgium to Finland, and finally the non-euro area countries, for which we did not construct a lower level aggregate series. Okay. The following methods can be called for the hierarchical Persephone object. We can perform a run, so we can perform the seasonal adjustment. We can generate a plot comparing the original, the directly and the indirectly adjusted series. And we can generate a user quality report. More methods directed specifically at multiple and in particular hierarchical time series still need to be implemented and or developed. For hierarchical objects, the F3 generic plot is the only plot function implemented at the moment. It shows a general comparison line chart comparing the original, the directly and the indirectly adjusted series. And as for Persephone single objects, it is generated with digraphs. Sorry. Another useful thing we can get for hierarchical objects is the Eurostat quality report. We generate it with the function generate QR table and get a data frame as a result, which can be easily exported. Okay, now methods developed for univariate analysis only can be used by accessing the components of a hierarchical Persephone object. For example, you can generate a Eurostat quality report with the function generate QR table for only one of the components, for example, the Persephone single object for Belgium. In this case, we have to include a lower level hierarchy EA19 here with a slash to access the component Belgium. Okay, as I mentioned before, with Persephone, we can also generate weighted aggregates. For example, for indices, the weights argument of per-HTS is used for this purpose. We can use time invariant weights in the form of a vector or MTS objects or an MTS object with the same weight for each time point is then created internally. or we can use, I'm sorry. Or we can use time variant weights or an MTS object or a named list of time series objects can be passed to the weights parameter in RJDemetra. We can have a look at the weights of an object by accessing the weights field here. And also a couple of time invariant weights are included in the package as example data sets. Now, these are our plans for the not so distant future. We want to include diagnostics for hierarchical time series, a benchmark method for direct adjustment, indirect adjustment of chain-linked indices, pure batch methods. So not only pure batch objects, not only hierarchical objects. A summary method or methods, and very important, a dashboard for large numbers of time series. And what I forgot to put on this list is some kind of changelog or a historicization where old settings or output can be stored and compared to new results, which is a nice feature we have in our X12 package at the moment and which we want to continue to be able to use. So, thank you for your attention and sorry, my throat.
Thank you very much for your nice presentation. We already have a question from the audience. Is this package already used in production?
Yes, it is. But only in certain projects, in a limited number of projects.
Okay, thank you. And another question. Are you using RJDemetra Plus workspaces at all? It looks you are saving the time series model specification in RCode. Is it so?
Sorry, could you repeat that, please?
Are you using the RJDemetra Plus workspaces?
No, I'm not. And my colleague isn't either for the, when he's dealing with Persephone, no, not with Persephone.
Okay, if we have other questions from the audience, please write them on the Q&A section. Okay, it seems that there are no more questions. So this concludes our afternoon session today. It was our last presentation. Now I give the floor to Alex for to announce some information for the section tomorrow morning. Please, Alex.
Thank you, Bogdan, for chairing the session. Thank you to the presenters. It was a really interesting afternoon session for me. Even for two of the presentations concerning Statistics Austria, you always hear something new, also from projects you are involved in. I just have one short announcement for tomorrow. Due to unforeseen circumstances, we won't be able to use the streaming infrastructures for tomorrow on YouTube and Facebook. So that means that people will have to join again via WebEx more actively. We are sorry for that, but maybe it's also a good opportunity to thank the Ecological University of Bucharest for doing that for yesterday and today for free for us anyways, but unfortunately it's not possible tomorrow. So please join tomorrow morning. We will start at 10 again, Central European time, and you should join via the WebEx link provided on our homepage. Thank you very much. Have a nice afternoon. Have a nice evening. See you tomorrow. Goodbye.
Goodbye.
See you tomorrow. See you tomorrow.
See you tomorrow.
Bye.